in touch with me here. I'm a developer advocate for Nebius. Quick show of hands, how many people heard of Nebius? Yeah, that's great. We are going to change that today. So Nebius is basically an AI cloud. There are a lot of AI clouds. There are a lot of generic clouds like AWS, Microsoft. Nebius cloud is purposefully built for AI workloads, right? Like we don't run databases, we don't run web servers. Only thing we do is AI. Anyway, we'll talk about this a little later. You can follow me here. I'll post updates. If you want to get in touch with me, email, all that works. My background is when I say machine learning, now a lot of people draw a blank because now everyone thinks it's AI. So my background is machine learning, data engineering, and cloud. And now I should say AI because nobody knows what machine learning is anymore. So and this is me. All right. So you guys all took a picture of this. And here's the basic agenda for today. So, like I promised, I don't have a lot of slides, but I do want to talk about a little about open source because Dave talked about this a little bit, the power of open source. So this is like an official Nebius slide. Again, like I said, I'm not going to spend too much time on this one, but I do want to walk you through a few things here. So we cannot do a talk in an AI conference without having AI to generate some jokes, right? So I asked agents, I asked a couple of LLMs to say, tell me a joke about AI agents, and this is what they came up with. And you guys are going to be the judge of which one's better, or they are both, they're all bad. So this is GPT-OSS, open source model from OpenAI, released in August, I think. Pretty popular, right? Not bad. Yeah, okay. And remember, we are going to do like a show of hands, A or B, right, in a second. So this is GPT-OSS. This is Gwen-3, one of my favorite models. What do you guys think? Decent? Good? Terrible? All right. So A is so GPT-OSS is A. So let me see a show of hands if you guys think that's remotely funny, like GPT-OSS. All right, a few brave souls think this is funny. How about Gwen-3? Anybody think that's funny? All right, I think it's a tie. All right, so we'll say it's it's AI generated content. We'll leave it at that. Anyway, what I want to talk about on a serious note is what I call rise of open source models. So this graph, if you see this, look at the timeline at the bottom, right? This is showing kind of when ChatGPT first came out, November 2022, I think, right? So on the top of the line here, where's my mouse? There you go. This is the proprietary model, the red line on the top. And on the green line at the bottom is open source models. So you can see in the early days, 2 years ago, 3 years ago, the gap was so huge. Like open source models were like so behind on proprietary models. And you can see as the time goes along, what happens, right? They're both improving, right? They are going up and to the right. But the gap is closing. You see this now, right? Which is great. Another thing you probably would have noticed, if you look at the timeline, how far does it go to? Just last year, right? So this is already out of date. Just letting you know. Because a year in AI is like eternity. So now, if you look at the summer of 2025, we had really great open source model releases. Some of the names you guys probably recognize, right? These are all great open source models that I use, and then also Nebius we host. Right? So let me talk about a little bit about these guys. And remember, this is just this summer, right? Summer of 2025, basically. And here's like a little more detail. You can see the release times, right? Starting in May, GPT-OSS, latest. I mean, again, this is missing a few that came out in the last month or so. But this should give you an idea of, how fast the models are improving and how rapidly new models are coming to market. And these are all open source. Everything I'm showing you here is open source, right? And if you look at some of the model sizes, look at the parameter column. Where's my mouse? There we go. Parameter column, right here. These are like pretty massive models. 300 billion, 200 billion, 400 billion, 1 trillion parameter sizes, right? This is crazy. Like 2 years ago, we would have never dreamt of like, we will have this high quality open source models available to us. Now we do, right? Which is great. And another thing you would notice, the context window is pretty high, right? They're like pretty much all around 120,000. What it means is these are really great for coding, right? If you guys do like, Cursor, Klein, any of the coding agents, it's kind of funny because somebody told me how we use LLMs have changed. Like when the LLMs first came out, we'll give them a small prompt. And then, so my prompt will be, write me an essay about electric cars in 2025. One-line prompt. And the LLM will generate like, 2 pages of text. So if you think about this, prompt is small, output is large, right? That's how we all started, right? But now, the way we use it is we give them so much information. We will say, OK, read my code base right here. Like, I have 100 files. And then write this tiny function. So I'm sending a lot of context to the LLM. Like, not my entire code base, but enough, right? Hundreds of, tens of thousands of tokens. And the LLM is just outputting back maybe like 5 lines of code. So you get to see how it changed, right? We've gone from small input to large output to large input to small input, small output. So what does it mean? What that means is context windows are important, meaning your LLM should be able to absorb as much information as you send because that's a use case right now. Pretty good, right? If you think about this, kind of, right? Kind of strange how things evolved. Any question on this one? Is it good? Yeah. So just to give you an idea of how good LLM models are. And again, if you have any questions, please find me afterwards. Connect me on email, whatever. So at this point, people ask me, OK, so yeah, these are great. You'll have all these great open source models. But how good are they? Right? Let me show you guys how good they are. So this is the benchmark from a company called Artificial Analysis. It's probably, and you probably will see them a lot on like LinkedIn, Twitter, because a lot of people actually use their benchmarks. So if you look at this, so the top models are still proprietary, like GPT-5, Grok, right? All that. Gemini Pro. But very close behind, you see what are the next models are open source. You see Gwen, right? You see OSS, DeepSeek. And look at the numbers. Look at the scores, right? And by the way, this score, people sometimes ask me, what does this number mean? So what they do, artificial analysis, is, because there are a lot of benchmarks, right? If you do a search for LLM benchmarks, there are like at least 100 that I know of. So it kind of exhausts to look through 100 numbers. So what they do is they kind of run a bunch of benchmarks, mesh them all together, and give you like one number. So think of it like your GPA, you know what I mean? Like just one number, which is great. So this way, as oversimplified as it is, you can just look at one number and say, yeah, how the models rank. So if you look at the open source models, they are pretty good. I mean, they may not be the top leaderboard, but they are very close behind. So remember the gap I talked about is very, very narrow. So what does it mean for us? Like, okay, so these are great, open source models, they are great, they are free. So what it means for us is now, as a developer, as a builder, we have choices. So you don't have to settle for proprietary models just because you want the performance. You can choose an open source model that gives you very close performance and gives you a lot of choice. Because there's no lock-in, right? Like, for example, again, this is not to single out anybody, but if you use OpenAI, that they are the only one with OpenAI, right? ChatGPT, right? But if you use an open source model, say Gwen 3, you can pretty much run this in any way you want. You can run this on your own. You can go to any cloud provider, right? Run that one on your own. So gives you a lot of choice. So that's what it means, basically, right? I mean, so I'm a big fan of open source. I've been into open source, and this is going to date me quite a bit. I remember a time, I used to use Linux a lot. When I buy a new mouse, you had to recompile the Linux kernel. I don't know anybody here can relate to this. This is like 30 years ago, right? So I've been a fan of open source. So it's great for me personally. It's really great to see all these open source models. Okay. So how do you run these models? Great. So you can run them on your laptop. Small to medium models you can run on your laptop. If you have a reasonable latest laptop, especially if you have a GPU, you can run a lot of small to medium models, right? So just to give an example, I have like a NVIDIA 3090 at home, like one of those gaming desktops, and it can run a bunch of these models, no problem, all locally, right? So I just download the model and run it, easy. But I cannot run these large models, right? Because these are, you can see the parameter count, these are pretty hefty models. I cannot run them, right? So how do you run? And the good news is a lot of providers are now offering to run these models. So you can go to pretty much any of your favorite AI cloud or Neo Cloud or hyperscalers, you can find these models, which is great. All right. So quick plug. This is where Nebius comes in. So I talked about, again, like I said, I won't do too much Nebius here. But Nebius Cloud is built for AI workloads, and what we do is we host open source models. And in our workshop today, I'm going to be using Nebius models, right? And the code I gave you guys will give you some credit, so you can actually use it. Yeah? So that's great. And again, very quickly, you probably heard of us. It's kind of funny because so Microsoft just made a big deal with us, and before that, not a lot of people knew about Nebius. So I was at a conference on a Nebius booth duty, and somebody came up to me and said, and that's the day the Microsoft deal was announced. They came and said, oh yeah, I just saw the Microsoft news, I just bought a bunch of stock, but I don't know what you guys do. What do you guys do? so I still remember this because this person read the news, they said, oh, hey, this company is going to be good, so they bought a bunch of stock. By the way, this is not financial advice, right? I have to tell this on the screen. So don't. But to me, it's funny. It's like they didn't even know what Nebius was. So anyway, but you will hear about us quite a bit. Data centers, yep. So again, very quickly, what gives us the edge, basically for Nebius is we control everything from hardware all the way to the software. Meaning we provision our custom hardware. Everything is optimized for AI workloads, right? Like I said, we don't run databases, we don't run web servers, right? We don't run AI workloads. All right. So the one we are going to be using is going to be called AI Studio. Actually, this slide is a little out of date. Now it's called Token Factory. We'll talk about this. And basically what it is, it's a way for you to run inference at scale. So let's say you want to say, okay, I want to use the latest open source models. You can just use an API, use as much as you want, and only pay for what you use. Right? No subscription, upfront pricing, right? No gotchas. And you can scale. You can start small, and you can scale to millions of requests easily, and we will handle the workload. All right. So I'll skip through most of this, but I'll just show you a couple of benchmarks here. One thing, since we run our control our own hardware, you can see, like, if you look at any other benchmark, there are a lot of benchmarks published. You will see Nebius kind of, on the top ranking in the performance, in price, and also quality of the service. Quality as in, like, how quickly we respond, what's the quality of our answers, and also pricing, right? And I know, right now money doesn't matter because there's a lot of money chasing, so people are just throwing money at this, right? But eventually money will matter, right? So if you're a startup, you're spending 100,000 on inference every week, and you come to Nebius and we can do the same thing for you for 10K, why wouldn't you, right? So eventually, yes. So think about this. So before we actually dive into the workshop, I really want to talk about what this RAG is all about, just to give you an idea, right? Because code is here, and these days I always say code is cheap because right? You can actually it's kind of funny. I was working towards this workshop last night, and I actually used coding tools to generate a lot of my code, right? I remember way back when I will write assembly code. Every single line mattered. Right? Takes forever to write code. But now, just go to some cloud or whatever, you say, write me a function to do this, or write me a code to do this. Click, right? So code is cheap. So don't stress about code. We have all the code on GitHub. What I want to show you real quick is what this RAG is and why we are doing this. All right. So very quick word about Alicat. By the way, the credit to the really nice logo should go to Dave. He came up with this. This project started as a kind of like a demo project. We just wanted to say, okay, what can we do to demonstrate open source AI? We said, okay, let's basically scrape a website, download a bunch of content from a website, index them, and then use LLMs to query about the website. That's the idea. And everything we are going to be using is going to be open source. And that's how it started. And so I did the initial implementation. I still maintain the project. But now what happened is like a lot of people kind of start seeing this and say, oh, cool, I have the same need. I'm kind of doing the same thing. Maybe I can use Alicat. So Alicat is now, people are using it, people are contributing, which is great. And as an open source enthusiast, it's really nice to see an open source project doing well. So what it does, I'll show you in a very nutshell. Let me see if I can bring this up. Yeah. There we go. So this is kind of a nutshell what it does. So we have a little website crawler that you point it to a website, it'll go and download the content. You can control how much to download, how deep you want to crawl, all that, right? That's the first step, crawling site. And then so when we do this, we are going to get a bunch of HTML pages. Then what we do, we actually do the cleanup. Just so you know, because HTML, web these days, right, it's terrible, right? There are like so many trackers, so many scripts. So what we do is when we download all this, we actually clean this up. And the way we clean it up is convert to a markdown format. And when we do this, we sort of eliminate a lot of this, a lot of the junk, ads, trackers, cookies, and all that, right? So then we get a clean markdown. Then what we do is we sort of process the markdown file, and we index the file, and we save it to a database. And these databases are called vector databases. You probably heard of them. There are, like Dave mentioned, there are so many companies doing vector databases. Can somebody shout some names, vector database companies? Yep. Anybody else? Any other vector database companies? Quadrant, yep. Oracle is, I think, doing that too, yes. I haven't checked it personally, but I'm sure they are, yes. Chromium or Chroma, right? They call Chroma, yep. Pinecone, yep. Milvus, Zillis, yeah. So the joke we say is now every database has to do vector search, right? Otherwise, nobody wants to use it. So even like the distributed database like Cassandra, I don't know anybody used Cassandra before? They're like very scalable databases, very good. Yeah, perfect. They are doing vector search, right? Because you have to, because the workload has changed, right? It's no longer about just doing simple indexes. Vector search has become really important. Anyway, so that's when right? When everybody's doing something, right? So there we go. So that's at step 5. Like remember, we downloaded a bunch of things, clean them up, save them, index them, and save them to a vector database. Then what we do, we ask natural queries. So you can ask questions like, what is the latest event? Or who are the members of AI Alliance? Like very human-like natural language queries. Then what we do at that point is we sort of fetch the documents from the database, send them to the LLM. Remember, this is how LLMs work, right? In LLMs, we send them a bunch of information, ask them a question, say, okay, read through all this and find the answer for me. And then they give the answer. So step 10 is my answer. So you can sort of think about this like, every single step, right? Starting with 1, 2, 3, all the way down. Step 10 is, when we get the answer. So what the workshop does, right? Or, and if you're doing it on your own, you will find this. We'll walk through every single step. So when we started this out, it's a pretty simple idea, right? It's like just crawl a website, index it, use an LLM to query. That was it. And even to this day, we kept it pretty simple because now we are finding a lot of people actually adopting this. And this is even being used as one of the as a tutorial by IBM, so which is great. Cool. So that kind of makes sense, kind of the high-level workflow. So this process that we are doing right now is called RAG, R-A-G. Because why do we need this? Because think about this way, right? Like if you can ask ChatGPT anything, but remember, ChatGPT is trained on public data, right? Or or data they download from New York Times, whatever, right? So, but it's not your data. Like if you have documents internally, right? If you have PDF documents, your emails, ChatGPT doesn't know about them because their data is basically public knowledge. So what we want to do is we want to basically use the same, but the LLMs have really good knowledge, right? But we want to use their knowledge, but in our own data. So the example I use is imagine you are you are a company, you are hiring a lawyer. So they already know the law, right? They went through law school, they passed the bar, right? They know the law already. But when you're hiring them, they become specialized in your company contracts, right? Partnerships and all that, right? So think about this, right? So you're kind of using their knowledge, but targeted for your own data. So that's basically what RAG is. So imagine hiring a lawyer, they become specialized on your own data, right? On a very simple example. Very kind of naive example, but I think it gets the point across. Anyway, so any questions so far on this one? Does it make sense to the high-level architecture? Why RAG is? Yeah. So like Dave said, RAG is useful. A lot of enterprise. So when a lot of enterprise adopt generative AI, this is probably the first project they will do because this is actually useful for them because they have a lot of documents internally which they want to digitize. Kind of query this way. And my favorite game these days is when I go to LinkedIn or Twitter. Every day, I will see this post, somebody saying, RAG is dead. I'm like, yeah, that's right. So anyway, so I want to make this a game for you guys too. So next time you go to LinkedIn or Twitter, whatever, social media, if somebody says RAG is dead, yeah, right? So just smile and move on. Because this is actually, like I said, even though this is not a coolest application, because the coolest application these days are agents and MCPs, RAG is still a useful application. Yeah. Anyway, so. Very good. So how does it work? How does it all work? So here, when we started doing this, we said our principle is like everything is open source. And I also made a decision to say everything should run locally on your machine. No need to sign up for API keys. Everything should run locally. And that was the original, very version 1, I would say. And that was great. It worked because everything runs on your machine. Dave and I did a lot of demos. All we need is all we need is just our laptop. Everything runs on our laptop. But at the same time, right, when you run on our laptop, like I said, even the models we run on our laptop. But these are the small models. So the answers they produce may not be all that accurate. They're pretty decent, but not great. So then people say, hey, I want to run a really high-end LLM, which is really big, which obviously we cannot run on a laptop. So how do we do this? So then we started doing this called RAG remote. So if you look at this, so the RAG local. So if you scroll down a bit, sorry, let me just show you here. So this was our very first setup, RAG local. So everything runs locally. And if you have a decent laptop, you can do it. And I would recommend you do this because this way you don't have to worry about creating API keys. There's no other dependencies. Everything's on your machine, right? But also it takes a little bit of work because if you have a laptop, if you have kind of a light laptop, probably may not work. Yeah. So the next one is remote, meaning so what we do here is we actually run these LLMs, these really high-end LLMs, on a cloud service. So I naturally chose Nebius because so that's why I work. But you can pretty much plug in any provider. So let's say you want to use OpenAI models. You can plug them in. It's completely open and pluggable. Or if you want to use Anthropic, or if you want to use any other cloud providers, easily plug them in. I'll show you how to do that. Yeah. So the reason I kind of had you guys started here is because if you were to try to set this up, the local setup, that's a pretty heavy setup. It'll download a lot of things, and as we know, if you're trying to do it right now, it may never complete. So do this at your own home Wi-Fi. If you're curious, you want to set up your local. Again, same thing, right? Just go there, right? I'll just walk you through. And basically, so the stack here, again, if you're kind of curious, remember we talked about a database. The one I'm using is called Milvus. It's an open source database. There are many open source databases. I just happen to use Milvus. You can plug in anything you guys like. It's pretty straightforward. And to run my model locally, I use something called Llama. How many people here heard of Llama? Oh, yeah, cool. Quite a few. That's great. Right? Very easy to use. But remember, right? Everything's running on your local machine. Yeah. And same thing, right? You can just follow the step-by-step setup, 1, 2, 3, and it'll get you running. Yeah. So, all right, guys. But what I want to do is very quickly is I want to show you walk through the remote setup. So, can we agree to this? Let me do a quick demo here, so you can kind of get an idea of how things work. And I know we only have 45 minutes basically at this point. So let me just do a demo. And if you're and after the demo, if you're using it, I'll come around and help you. But remember, and then you can continue working on your own time, right? This way we we don't get stuck on like setups and whatnot. Yeah, sounds like a plan. Okay. All right. So this is my directory. Let me see. It's larger, so you guys can see better. So this way, I kind of watch it on my screen, and then you can answer on your own. Easy, right? And so what I'm going to do, I'm going to do RAG remote. Oh, one more thing. Sorry, this is what I was going to say. I forgot. If you are wondering how to use this code on Nebius Token Factory, let me set you guys up. So here's what you want to do, right? I want you guys to go to, you can just type it in, Token Factory, Nebius.com, right? That's a new rebrand. If you guys heard about NVIDIA's Jensen talk about how everybody is building AI factories, it's a kind of play on that theme, right? Token Factory, Nebius.com. Let me show you guys how. I want to make sure you guys are onboarded, so this way, right? No surprises. All right, if you're there, you can log in with Google or GitHub. Either way is fine. All right, go ahead and log in. The first time you log in, you just have to provide some basic info. Just do that. And so once you're logged in, you should see all the models that are available to us. All right. By the way, I forgot what it is now. We do give some free credit, but it changes, month to month. I kind of wonder if anybody signed up for the new account and how much credit they got. $1. All right. Okay. Before we so $1. Just to kind of put things in context. It was like $1, only $1. So take a look at this. So this is GPT OSS. Look at the price. For 1 million tokens, it's only 60 cents. So with $1, you get like a 1.5 million tokens, which is a lot, right? So yeah, so don't despair. Even if you have $1, you can still do the workshop. But I'm going to give you some extra credit. Don't worry. But even if even if you just have $1, don't worry. You can still do the workshop, right? So no excuses. So we always talk. Remember. So, and by the way, when we talk about this pricing, and this is pretty much universal. People will publish pricing and like price for millions of tokens. Let me ask the question here. If you look at this pricing, why are these two different? Like, can you see what I'm highlighting? Why are they different? Input tokens, output tokens. Why is output tokens more expensive? Right, because remember, to generate, so input token is what you are sending to the LLM, right? So LLM just had to read it. Output token is what the LLM is generating. Like for example, if you're ChatGPT, if you're talking, say, asking ChatGPT, write me a poem about cats, that's your input. So ChatGPT will read that. Right? That's pretty straightforward. But now it has to create a poem about the cats. That's generation, right? And the generation is always expensive, right? Because they are running on GPUs, right? They are using a lot of power. So most of the time, I mean, almost always, you will find output token pricing higher than input token pricing. Yeah. So anyway, just to kind of give you an idea. And you can see where the data centers. By the way, you will see like a lot of EU North data centers because that's where we started. This is in Finland, by the way, if anybody is curious. So just a kind of quick trivia, little tidbit. Data center, the heat they generate is recycled to heat homes in the nearby towns. Right? That should give you an idea of a data center heating up the whole village. You know what I mean? That's literally is the case. But at least here, we are putting it to good use. If you go to our blog, you can read about this. And you'll see like more and more data centers built this way. They don't just dissipate heat into open air. They will capture the heat and use it to whatever, right? Heat up homes, heat up water, or whatever. So anyway, so this is one of our very first data centers. And if you scroll down a bit, you will see you start to see like US data centers. Let me see, there we go, right? So here, DeepSeek R1 is US data center, right? So yeah, so we actually have data centers in Europe and EU, US. Why this matters, again, just again, not just Nebius thing, but it's a general thing. A lot of our customers are very data sensitive. A lot of European companies will say, we will not send our data to US, right? Because EU, as you guys know, has very strong data protection laws, so they are very particular, right? So and this is just not us, right? A lot of cloud providers will have distributed data centers in different geos because there are sometimes your data has to live within the geo region. Right? Anyway, just a little few things. Let's see, what else I want to highlight here. Can somebody tell me why Kimi K2 output tokens cost more? Just a little quiz. ChatGPT OS, GPT OS is like 60 cents. This is like like 4 times the price. Why is that? Okay, yeah. So these are both text-to-text model, yeah. But that could be a good reasoning. So somebody was saying here. What was it? Anyone remember the parameter size on these? 1 trillion, remember? Yeah, so 1 trillion is not cheap to run, right? It takes multiple GPUs to run this thing, right? And so they consume power, and we had to charge you for it. Anyway, so we're seeing the pricing is kind of interesting because see, right? Not always, because sometimes we will discount the pricing if the model is very popular and we want people to adopt the model. We will discount the pricing, right? But yeah, so just to kind of just see them side by side is very striking, right? Anyway, yeah. So okay, what matters is this: how to apply the code. So you guys all have the code. By the way, please don't post this code publicly because if the system discovers the code is being abused, it'll shut down the code, right? So please, this is just for you, and that's why I'm only showing it here. On the on the slides, like we didn't send this out on email or whatever because the system automatically will block the code, and that's it. Then the code is invalid. So please, be careful. So you copy this code, TechEquity, the whole thing. Right? You go to Nebius. You'll see a button called Top Up all the way to the right. You see this? Yeah. Click on the Top Up. There we go. You don't have to enter the credit card, right? You can say promo code, and then you punch in the promo code. That's it. So that's how you redeem the code. For some reason, if the code doesn't work or whatever, if it's used up, don't worry. Contact me. Like you can follow me on whatever, Twitter, email, whatever. I'm happy to give you a different code. So don't worry, right? And then you paste the code, right? That's it. And then I will not do this because I don't want to take this from somebody. So, and your balance should show up here. And if you're wondering why I have high balance, because what I do is every time I issue a new code, I test it just to make sure it's working. So as we distribute the code, my balance keeps going up. Anyway, so yeah, it's not like and then you'll see how you can see all the activations happening here, right? That's it. Show of hands if you're able to activate the code. Nice. Nice, very good. And remember, right, this code is valid. You can, it doesn't expire. Just use it. So again, I hope everybody took a picture of this. If not, this is the last chance with the code. Because now it matters, right? It's not like some link, it's actually money. Money as in, credit. So last chance to take a picture and use it. And if you have any issue with the code, just, ping me on LinkedIn, email, whatever. All right, guys. So good. So hopefully that's the logistics. So that's basically it, right? So that's how you start using the code. And how do you start using this? You go to models. Very simple. And if you use ChatGPT or whatever, you should know how to do this, right? Click, go to Playground. Right, this way you can set on the console, and you can say, say write Python code to convert CSV to JSON, whatever. Right? And there you go. Right? Simple, simple, simple. And then if you want the code, very simple. You can just click on the view code. All right. And let me show you this real quick. Actually, this is important. Oops. Yeah. Sorry. So how did I get this? I click on the view code here. And this is literally code you can copy paste into a file and run it. And if you look at this, you might see we are using OpenAI API. Right? So this is not by accident. So this is what we call OpenAI compatible, right? Because OpenAI came up with this first, right? They were very popular. So and then we also said, oh, you know what? Let's just stick to the same, using the same API. But the way we go to Nebius, you can see, right, is here, right? We point to a different endpoint. So now the requests go to Nebius. And this is just not us. A lot of providers do this way. We use OpenAI API. So if you're using OpenAI, literally it takes one line of code change to try somebody else, as long as they are using the OpenAI compatible API. And then in the code, here's how you get the key, right? So that's it. Very simple. So if you want to try it out, if you're doing something, if you want to just switch, there's not a lot of code change. Literally one line of code change, maybe 2 lines, right? With the API key, yeah. So anyway, that's how you use it. Yeah. And let me show you a few things here. When you're using the tokens, right here you will see the token speed, right? Tokens per second, which is pretty good, actually, by the way, right? This is something I'm going to look for. This is like a game. I sort of, whenever I'm running these models someplace, right? OpenAI, wherever, I look at the token speed, like how many tokens per second. That tells you how, right? How fast they are running the models. So, even in our system, some models are faster. We are like one of the fastest one for ChatGPT. GPT OSS. But there are some models not as slow, not as fast, right? Because they're not don't have enough. We have a lot of capacity allocated for popular models, and they are very fast. Anyway, so those are some tidbits I want to highlight. All right, so that's how we use the token factory. And another thing, this is very simple. I'll just show you real quick if you're curious. And you can use in any provider. You can compare different models. All right? And give them the same task. Let's say how they do, right? Let them go side by side. And you can see the speed, right? Pretty cool. This is kind of a little thing. Again, this is just, even though I'm showing it in using our token factory, this is a very common technique you can use in pretty much any provider. If you're kind of curious how fast the models are running, right? How fast they produce output, something like this. Yeah. And you can see, right? This is done. This is still going, right? So yeah, just to give you an idea. And you can see, look at the tokens per second. So it's like almost 200 tokens per second, like 30 tokens per second. Right? So anyway. Good. Any questions so far? Oh, the data center locations? Sure, yeah. Right here, you mean? Yeah. Oh, yeah, okay. Okay, so picture one more time? All right. All right, there we go. All right. Sure thing. All right, guys. Let's oh yeah. So yeah, we don't. Yeah. So another thing. So that's not a bug. That's a feature. So the question was, it doesn't save my chat. This is true, and this is by design. This is called zero data retention, meaning we don't save any of your data. We don't save your data. We don't use your queries to train our next model, unlike some people, right? No, we don't do any of this, right? This is what, honestly, I'm not kidding you. A lot of enterprises, when they come to us and say, yeah, zero data retention is our #1 priority. We want to make sure you're not saving our data, you're not using anything, anything that we don't want. So we don't save anything, right? So it's not a bug, it's a feature. Thanks for asking. Yes. All right, okay, workshop. I need to get to that. So, all right, I'm going to walk you through the workshop, and you'll see how easy it is. It's in GitHub. So I'm going to walk you through the GitHub. And guys, again, like I said, you can watch me on my screen. Let's just focus on the sort of the big picture. And and if you're running it already, that's great. If not, you can run it on your own, right? So don't stress out. So I'm on the main page, AliCAD. Scroll down a bit. So I'm going to run the remote configuration just to kind of show you how you can use Nebius, right? And I'll show you some of the best practices and things like this. All right, click here. All right, I'm going to go step by step. So I got the code. Yep, I have it. I done the setup already. And remember, most of you are probably at this stage. That's fine. That's fine. Don't worry about this, right? By the way, this is just another little tidbit. When you're using Python, you can use quick show of hands. How many people are using Anaconda or some version of that? Anaconda Python? Yep, quite a few. How about plain Python, just Python? Yep. Anyone move to UV? All right, quite a few. So, just if you're kind of curious, if you're kind of a Python developer, right, I would recommend, so I used to use Anaconda until about a few months ago, and now I started using UV. It's actually very good. So if you're a Python developer or new to Python, you want to kind of switch over, UV is the Python package manager, which is pretty great. You should definitely try it out. Because one of the things in Python is package management is not, okay, let's just say not as great as some other systems, but UV makes it really easy. So yeah, so if you're kind of trying to try something new, try this out. You'll be glad you did. All right. So if you look at the end file, so remember in this case, I'm going to run my models on Nebius, right? So for this, let me show you the code. And the way we do this is by checking. So this is a RAG remote. You can see this here. And I have an env file where we store, right, all the configuration. So remember the Nebius API. Oh, by the way, how to create the key? Yeah, somebody just asked me. Good question. 1 second. On the Nebius Studio, it's very simple. You simply go get API key. That's it, right? And when you do this, and just another best practice here I will show you, when you do the API key, you can see the current keys. Let me see if I can show this here. There we go, right? I recommend, you just need one key, right? So that's just need one key. But what I recommend is, if you have different projects, create keys per project. So this way you can track the usage and see how much money is being spent. You see I have a default one, and I have a one called client. So this is my coding agent I use. So I kind of want to see how much it's using, right? Again, like I said, just need one, right? Just to be sure, just need one. But best practice I recommend is I like to create them on a per project basis. All right. So again, like I said, right? So don't think of them as like a Nebius specific stuff. These are generic thing. If you're using any provider, just some best practices that will serve you well. All right. So that's my API key. So by the way, when you create an API key, and this is true for most people, you have to copy right away because like we don't show the entire key here for security reason, right? So like don't close the window without copying the key. But even if you did, just create another one, right? So not a big deal, but anyway. So you cannot go back and copy the key again, right? And the key is basically stored in an env file, right? So that's it. An env file is where we can configure a lot of other things. Like, for example, if I want to run different models, I can change my env file. But for now, the only thing I need in my env file is the API key. That's it. OK, so let's see. So I'm going to just keep going, right? All right, so I'm at step number 4. We're going to crawl the website. Remember, that's the very first step. Remember, actually, I should push that up. Remember, this is a workflow, right? Step 1 is crawling the website, and it's very simple. If you look at the code, what I've done is the code literally has step number 1, 2, 3. So I should just run the steps. So this way, this is for me mostly because I don't forget. So the question was, do we need to build our requirement file? So again, this is I'll just show you this real quick. So this is a UV project, right? Again, remember we talked about different Python environments. So UV projects, they track the dependencies in their own file. It's called project.toml. Same thing, right? It's very similar to requirement.txt, but it's much more controlled because this way they have the exact replica. They can create the environment in other machines. So what you can do, and what I do, not everybody might have UV. So what we also do is I generate the requirement.txt. Let me show you this. If you see my requirement.txt file, you can see it's very detailed. Like how many lines is that? It's like 100 lines, even more. Oof. 1,000 lines, right? Why is that? Because this is actually generated. You see that right here? This file is generated by UV. So to me, and this is the best practice if you are using Python, this is my source of truth. UV is my source of truth. But we also understand not everybody will have UV installed, and they may want to use requirement.txt. So then what I do is I create a requirement.txt file automatically. And if you look at this, this is very detailed, right? I mean, a lot of the requirement.txt file I see, they don't have version pinned, right? They will just say, oh, install OpenAI, right? Or install package X. It's very important to specify versions. Why? So you can reproduce exactly, right? Because, for example, if I run this today, let's say I get, let's look at this one, right? What are the packages? Let's say I get 3.13, and somebody did this, like, say, next week, they make a 3.14. What if there's a bug, or they're not compatible, whatever, right? So this way now, even though they said, oh, I just did the pip install, it's not working. Because why? They got a different version. So again, another best practice we are using Python, definitely pin versions. And for me, UV does it for me. And the way I generate this is very, very straightforward. Like, let me show you right here. If you look at the README file, all the way to the bottom, you will see David notes, right? This is the command. So, and anytime I change a dependency, I just run this command. It will create a requirement.txt file for me automatically. Yeah. So anyway, good question. Thanks for asking. All right, so we are going to run crawling the site. So this is my first command. So I'm going to crawl the AI Alliance website. So again, hopefully this works. Which Python? Let me make sure I have the right Python sourced. Yeah, so you see this here, right? I'm actually in this Python, in the VN Python, right? So this is the local environment I just did. All right. So let's see how long does it take. Hopefully this works. Oh, sorry, of course, yeah. I should go to RAG remote. All right. So all this is doing is going to crawl the website. Let's see. There you go, right? So the very simple crawler, I'm just pointing it to a URL. It just goes and download the files. It'll follow the links. You can control how deep it needs to go. I think by default it's downloading 100 files, right? 100 pages, I should say. And then you'll just save them. And that's it. Right? That's the very first step. Nothing, nothing earth-shattering. Just downloading a bunch of websites, right? Just crawling the website. All right, and that's the first step. While that's doing this, once that is done, remember, we are downloading a bunch of HTML files, right? And if you can see this here, right? If you see this in the code, you can see in the workspace directory. Right, you can see the crawl files. You see a bunch of HTML files. And these are not, how do you say this, as they are, right? Meaning like with all the, all the scripts and tags and formatting and everything. So these are not really ready for querying because there are so much, so much stuff in them. We need to clean them out. And that's the next step. Is this still running? Okay, so where am I? 90, okay, 90, okay, almost done. Next step is we are going to clean the file, and that's very simple, process files. Right, I'm going to run this command. There we go. Scripting is done. Next step, I'm going to process the files. So for this, we actually use a package called Docling to do the cleanup. So Docling is actually pretty cool. It's actually a deep learning library. It can process pretty much any, it can extract content from any file, HTMLs, PDF, Word documents, what have you, right? And so it's actually uses a machine learning model, or I should say deep learning model to do this, which is pretty good. So especially its PDF processing abilities are very good. So it'll take a while because it has to download a bunch of models beforehand, and then it'll kind of convert them, right? So hopefully this will go through. Let me see. I'm just hoping Wi-Fi is not too bad. Yeah. And then so if you are wondering about what Docling is, you can see this Docling. and they're pretty popular. And you can see, right? You can pretty much throw any file format at them. You see PDF, docs, PPTX, HTML. They will process them and then create you can export them out in JSON, Markdown, whatever format you like. It's even pretty good. Like I use it all the time to process PDFs. Like even if you have tables and things like this, you can actually extract data out of them, which is pretty nice. So yeah, if you kind of have a need for you need to parse documents, things like this, I would definitely try Docling. Open source. There you go, right? So it's done. So process the files. Here we go, right? So what it does is it basically creates, again, if you look at the workspace, under process, see I have a bunch of Markdown files. So now these files are much cleaner than HTML. Right? So we had step number 2. What is step number 2 is we crawl the website, convert them to Markdown. Then what we are going to do, and this is kind of a sort of a RAG step, we are going to basically we are called chunking. Chunking basically means split the document into small pieces. The reason is some documents can be pretty large. Like let's say I have like a 300-page PDF, right? You don't want to store this as like a one unit because now when you're searching it, you had to read through all 300 pages, which is probably wasteful, right? Because the information is probably in one page. So why keep the whole thing as one unit? So what we do is we split them into chunks and then store the chunks. Now at this point you will ask me, okay, so what should I divide the chunks as? Is it like page by page, paragraph by paragraph? There are a lot of chunking mechanisms. I think by default it's per page, I think. I need to double check. But yeah, either way, like something manageable, right? So you're not like, when you're doing the search, you're not loading like 300 pages just to go through, like just to read 2 pages. So these are called chunking techniques. If you do a search for it, even like a simple page by page wise is okay, but it's not, it may not be, it's a good starting point. You can try it out. You can try page by page or paragraph by paragraph or some other structure. So anyway, and that's the next step, literally. So my next step, so we're done. So we are going to save this into a database. Let me copy this. And here, right? This is step number 3 here, right? We have documents formatted in Markdown. We are going to take the Markdown, slice them into pieces, index them. By the way, when I do this, okay, yeah, so we also index the text. So what we do is we convert them into what we call embeddings, right? So what embeddings mean, I'll show you what it means. Yes. So what it does, so we have text data. So we cannot search text, right? Text has to be converted into numbers. But how do we convert text into numbers matter, right? Because we can assign like random numbers because then there's no point. What embeddings do, hopefully this loads actually, yeah, because it's downloads a lot of data. So it converts the text into numbers or vectors. What that means is that they are easy to search. So instead of searching text, we're actually doing vector search, and that's what the whole this whole premise of vector search is. And it doesn't have to be text. Like somebody was just saying multimodal, like images, videos, right? All of these you can convert them into vectors. Why? Because rather than searching like an image, which may not be fast, searching a vector is like vector is just a bunch of numbers, right? It's much faster. So that's why embeddings are great. Okay, so this will take some time to load, so I'll kind of keep going. Let me see how my process is. There we go. So it's done. By the way, right? So here I'm using a software called Llama LLM to call my Nebius endpoints. So this is actually great because, for example, let's say you are trying, you want to try a bunch of different providers. You don't want to hard code the providers in your code. Right? So let's say you want to try OpenAI and Together, Nebius, and AWS, whatever. You just want to try them out. So one other package I will recommend is called Llama LLM. So what it does, this is actually pretty cool. You can, there we go. Actually, yeah, I'll go through this here. Llama LLM. This is an open source package. What they do, using a single API call, you can basically call any model. So your code doesn't have to change at all. You just change the configuration, right? So for example, if I show you here, if you should look at my .env file, right, there we go. See my LLM model? I call Nebius/model name. So Llama LLM knows, oh yeah, this is Nebius. So it'll actually figure out, okay, what the endpoint for Nebius is, and it'll call the Nebius API. You could say, in this case, here if you said OpenAI, I say, oh yeah, okay, I'm going to call OpenAI API, right? So it's very simple to switch providers and experiment. Just like I said, all I'm doing is I'm just changing my .env file in my config, right? I'm not even changing anything in the code at all. So if you're kind of if you're trying different providers and switching around, this is a great way to do. And I'm a kind of big fan of this project. It's open source. You download it. It's a client library. There's no API keys or anything, right? It runs on your machine, and then it'll select the provider for you. Pretty cool. Yeah, so what I'm using is I'm using Gwen3 embedding. Yep. So actually, it is commented out, but we use it by default. Yeah, so right. So if you want to override it, by the way, right, just to kind of, if you're wondering, how these models are coming by, if you go to my studio, right, you go to models, right, you can select by text-to-text model, embedding models, right. So embedding models here, right. So I'm using Gwen3. So I'm a kind of a fan of Gwen3 models. So I tend to use them a lot. But remember, you can change any of these, right? You can just, you can say, hey, I want to run BG ICL. Sure, right? Just change it in your .env. So, let's say I want to use this model. I'll just change this into I'll just make this up, right? If we are doing it here, I'll just change it to say embedding model, right? Something like this. That's it. Easy. Okay, we'll take a look. Yeah, we'll take a look. No worries, right? All right, so that's my env file. Any questions on this one? So what we are doing right now, right? I want to make sure you guys understand the big picture, right? That's important. And the code. So we are at this stage, right? So we are taking the file, markdown files, split them into chunks. Every chunk is converted into vector. What am I using this, right? When I vectorize, I'm using the embedding models. So yeah, so let me show you how the embeddings work. So by the way, if you do a search for embedding projector, you will get this page. This is one of the original embedding programs. You see this bunch of dots? Like if you move your mouse over, these are just words. Like every dot is a word, right? And they're kind of projecting, imagine they sort of projecting them like they in a three-dimensional space. They give 3 coordinates, and and that's what these are, right? So you can sort of rotate them around, whatever, right? And if you move your mouse over, these are the words. And you're like, what's the big deal, right? Bunch of dots. So the big deal is, so let's say we search for a word. Let me do reset here. Let me reset. All right. So let's do a search for, say, apple. Oops, no. All right. Shoot. All right. It's kind of hard to see, but probably you can see it better on your machine. All right. This is the word apple, and all the words that you see right now are somehow related to apple. You can see this? Okay, let me see. Even let's see, disk, processors, right? Video. So now they're kind of thinking Apple and see Microsoft, right? So now they're thinking Apple like a company, right? So these are kind of related words to Apple. How does it work? Because because remember we converted them to numbers, and when we do them, they kind of capture some meaning. So when you search, the search is very quick. When you search for Apple, you're only going to get Apple-related entities. Let me do one more. Let's say King. All right. So King is what I want. There we go. That's a word. Did you guys see, again, I don't know if you noticed, remember all my Apple words are on the top? Remember, right here? All the King words are at the bottom. Because they're two different entities, right? There's no relation between Apple and King. So they are they occupy different spaces, so to speak, right? So if you remember, the Apple was over here. The king, again, remember, these are the related words for kings, right? By the way, these are the top matches: king, kings, queen, throne. These are the related words. Pretty cool, right? And you see this, and you can type in, you can type in any word you like. Okay, let's do one more. Let's do one audience suggestion. Can anyone shout out a word I want to search? AI. Ooh, okay. Why not? So this is interesting, right? Because remember, this is an old one. at least like almost about 10 years old, they don't have AI. That's interesting. Let's do something else. See? Somebody showed me something. One more? Coffee? Okay, why not? Sorry, okay, let's do coffee. Sorry, yeah, that's what I heard. There we go, right? Look at the top matches: tea, sugar, cotton, cocoa. All right, not bad. Remember, this is the 10-year-old model, right? So this is not going to be like state of the, it's not going to blow your mind, but you get the idea. This is why we do embeddings, because embeddings, when you search for a word, you get not just the exact word, you also get the related words. So for example, if you open your Google Maps right now, and you do a search for ice cream, sure, you get ice cream places, but you may also get bakeries or donut places. And you might say, wait, I search for ice cream, why are they showing me donuts? Because remember, they're kind of in the same thing, right? They're kind of saying, oh, you're searching for ice cream, maybe you're looking, you are looking for a dessert, so we will show you donuts, we'll show you boba places, right? So this is basic idea. Right? So anyway, so that's why embeddings work. Anyway, hopefully, that gave you a sense. But the models we have now are much better than these, because remember, this is like a 10-year-old model, but I like the visualization, so you can kind of visually see how the words relate to each other. And the one I'm using, right, you can choose, like if you go to you go to any provider and you can choose the models, embedding models. This is what we have. These are all open source embedding models. Gwen 3 embedding models, what I'm using, right? You can see, right? It produces a vector at like 4,000 length, so which is a pretty high dimension vector, right? So that means the quality is pretty good. Anyway, so moving on. So we basically did this, right? We are here. So the hard work is done. We crawled the website, did the cleanup, Now everything is nicely indexed into a database. So now it's time to query. So here's how we query. That's my next step. Oh, go away. There we go. All right. All right. Let me do the last step. Query. So this is remember, this is what we've been building up towards, right? So again, we have a UI, but I'll just do the command line version just for sake of time. All right. So everything's indexed. Let me run the query. Fourth and final step. Just ignore this warning, just like some version incompatible thing. All right, so what we're going to do is going to load up all the data, and when I run a query, right, what's going to happen is now you guys know the process now. So when my query comes in, let's say I'm asking a query, first going to go to the database and say, okay, give me all the documents that may have the answer for the query. Not the actual answer, mind you. Only the documents that will have the answer, right? So let's say I have 10,000 documents in the database. I'm asking for like, what are, let's say what's the revenue for 2025? Maybe it's only in like one document or maybe two documents, right? So there's no need to fetch all 10,000 documents. And that's what the database is doing for us, because it's going to, just give us only the document that have the answer. But it doesn't give me the answer. Right? So this is kind of similar to Google search, right? When Google search, the Google search, as we remember it, like you search for a keyword, they give you a bunch of links. Then you're supposed to go click on the links, and then kind of, that links has the answer. Like for example, most of you probably know Stack Overflow, remember? Right? So if you had a question like, how do I do this in Java? You go to Google, you type it up. Probably the first link is Stack Overflow, and then we go click on that, and then there's an answer. And I always copy the first answer and copy paste it, hoping it works, because all these people are, all the people said thumbs up, so it must work, right? And then move on. Right? Anyway, this is what we did 3 years ago. By the way, did you guys know after ChatGPT and all the LLMs, the traffic to Stack Overflow is down by 40%? Yeah, see? So yeah, this is kind of amazing because just in 3 years, right? Because now why? Because now we don't have to go to Stack Overflow. Why? If you go to Google or any search engine, how they have this AI mode, right? They just give you the answer. I'm like, yeah, that's great. I don't even have to go to the site. So this is great, but just on a side of the thing, think about what's going to happen to all the websites that rely on traffic. Now, they're not getting traffic, because why? Because, Google just gives me an answer right there. So what's the incentive for me to maintain my website? Because, before I will do all the SEO optimizations and everything just to rank high on Google, so I get traffic, I can serve ads, I can get money. But now, all my content's indexed by the AI, and I get no traffic. So think about this. I don't have the answer, just something to think about. Anyway, so this is the old style Google search, right? So this is going to give me links. So we are going to send those content to the LLM, and then say, hey, here's like 3 documents that may contain the answer for the question. Read through this, and here's the question, give me the answer. Right? And this is what LLMs are great for, right? They can read a bunch of things and then give you the answer. Right? So that's what we are doing right now. All right, so okay, right, my command line thing is up. So I can say, let's say, simple, what is AI Alliance? Right, so this is my very simple query. Right, remember, we are going to go to the database, fetch the pages that possibly may have the answer, send them to LLM, right? And then this is going to come back with the answer. Right? So all this is happening in the back end. All right, so let me show you what really happened. All right, so there you go. Here's the response. You can skim through it. Right? Here's the answer. Right? And then it actually is showing you how it found the answer. So these are the files that actually it found the answer. So this is great because this is something you want to. I'm printing it out so I know how did they find this answer, right? Which is great. So see, remember all these markdown files we indexed, right? So that's one. Is it only one file? No, 2, right? One is AI members, and the other one is like right? So these are the pages that they're able to find the answer. Pretty cool, right? And let's do one more. Let's say, who are the members of AI Alliance? That'll work, fine. Same thing, right? It's going to go grab a bunch of pages, send them to the LLM. It's going to read them through, and hopefully give me the answer. There you go. Let's see, scrolling up. There you go. Right? These are all the AI Alliance members. And it's able to find this answer in this page. Not surprisingly, AI Alliance members. Pretty cool, right? So this is not a keyword search anymore, right? This is like context. You're asking like question in like English, like in a natural language, and it's doing the work behind us. And that's the power of this whole thing, right? Even though it's like idea is pretty small, when we set out to do this, we actually wanted to demonstrate, hey, this is possible. So your website doesn't have to just do a simple keyword search. You can actually have a conversation, right? All right, one more thing. So, okay, oh, by the way, just, this is one of my favorite things. When was moon landing? Anyone know the answer to this? 69. So question is, so I'm asking this is public knowledge, right? So any LLM should know this. Now the question for you guys, before I kick over the query, am I going to get an answer? Yes. No, maybe. Okay, you guys covered all the bases. Okay, let's see what happens, right? So this is an interesting, very simple query, but I want you guys to understand the importance of this. All right, let's see what we got. Interesting, huh? What do you guys think is going on? Yes, it's limiting its answer only to the context. So it's not freelancing, it's not performing a Google search to find out when was moon landing, right? It's only limiting the answer to the context is provided. This is very important because you don't want your LLM to freelance, right? It should answer the question only from the documents it's given. Imagine, right? Imagine the case if you're like a WebMD, right, or like some healthcare company, a hospital, or a financial institution. Do you really want your LLM to go and kind of freelance and kind of guess the answers? No, right? Answer should be found in the context is provided. So anyway, so probably, maybe this is like one takeaway. When you're testing this RAG system, I I kind of punch in this query, when was moon landing? Some very public knowledge thing, right? And you should not get an answer. If you do, that's a bug. Because if you do, that's not a feature, right? Because that means now the LLM is basically going outside the context and giving you something from its knowledge base. And by the way, every LLM will know this, right? You can go to any LLM, ChatGPT, whatever, just type the answer, they will know this, right? So this is the very old knowledge. But here we are showing you why it should not give you an answer. Pretty cool, right? Anyway, so that's it. Let's see, what else? So let me exit here.
Your question was ambiguous because there's more than one moon landing.
So I should have said when was the first moon landing, right? Yeah, good point. But I can pretty much guarantee you it'll come back and say no context. But that's a good point. You're right. Yep. All right, guys. So let's see how we're doing time. Okay, perfect timing. So what we've done, again, this is a demo, right? Again, you can run this on your own time. Down the website, indexing, answering the questions, right? And we have a UI. So again, if you go through a README file, you can run the UI. I will leave you to it. Also, another cool thing, I want you guys to try. So this is just a RAG, right? So it's answering the questions you're asking. What I wanted to do, I wanted to use this with other tools. So what I did, and I did this last night, I turned this RAG into a MCP server. So what does it mean? MCP is basically a kind of a very common protocol for you to talk to a model to talk to outside services, right? So you can pretty much use any model, and that model can actually talk to my AliCAD RAG and find answers. Pretty cool, right? So let me show you. I don't know if I still have this configured. I'll be very brief. So, all right, let me start this. So what I'm defining here, so again, this is kind of a little outside the scope, but what I'm doing here is I'm basically, you can recognize the command, right? I'm writing an MCP server, and if you look at the MCP server code, all it does, right? Let me show you. And right? And you recognize it's initializing the embeddings, initializing all the models, right? All the stuff, right? But in addition to this, it's also providing MCP interface. The reason MCP took off is it's dead simple. I mean, at a very basic level, there's only two queries. First query is, what are the tools you have? That's list tools. So it says, oh yeah, I have this tool called AliCAD RAG Remote. And it takes one input, right, which is basically a string. See, input type is string. That's it. So it's only saying, I only have one tool available for you. The tool name is AliCAD RAG, whatever, right, remote. And this is the description, and these are the schema. And that's it. So now any LLM can say, oh yeah, cool, I want to call this tool. And when they call this tool, they will actually execute the tool call. That's it. So a lot of people get hung up on MCP. It's that simple, right? It's basically a unified interface and very simple interface to talk to people. By the way, anyone here used SOAP, S-O-A-P? This is way back when. Remember, this is what we did. We used to say, when two services want to talk to each other, we came up with this elaborate XML schema, which nobody could understand, right? And we said, this is the standard. And obviously, nobody used it. It failed. MCP, you can see, just literally two functions, list and call. That's it. No schemas, right? None of the crap, right? So anyway, so the reason is as you see these evolution of tools, now the tools are much simpler. The interface, talking to other tools is much simpler. We don't need complex XML schemas and all the nonsense that all the enterprises came up with, right? MCP just, just like I say, show me, list me the tools and execute the tool. And when you execute the tool, what is it doing, right? It's basically taking the query, right, and running the query and give you the answer. Let me see if I can do a quick demo, and then I will hand over to Alexei. Here's my VS Code. All right, show output. So if you can see here, I don't know if you can see it, right? You can see, right? See, you can kind of see my, my RAG system is up and running. But the beauty of this is actually I can query this RAG system see if I can show this here. There we go. So here I am on the in the chat. So this is like a GitHub Copilot, and I can use any tools. And if you see this, you will see. Sorry, I'm kind of moving this around. If you go here, see, MCP servers install, GraphRAG remote showing up right there. How cool is this? So now, if you use GitHub Copilot, now the Copilot can actually query my RAG for any AI Alliance-related stuff. So let me show you real quick. So let me configure here, right? Let me go to Tools and search for AliCat. There you go, right? So I have this checked. So I'm going to go and say, same question, right? I'm going to ask them same question. Who are members of AI Alliance? Hopefully, what should happen is it should invoke my MCP server, this guy right here. It should then in turn go to my RAG system, do the query, right? It should do the whole thing. Let's see what happens. Right? So now what should happen, right? It should execute this whole side of things from within VS Code. Pretty cool, right? So let's see if this works actually before I get too far ahead. Enable. So hopefully you should find the AliCat RAG tool and invoke it. So we'll see. There we go. Yeah. Answer should be coming up. So what I've done on a very high level, again, this is just mechanics. On a very high level, I have exported my RAG system as an MCP that can be accessed by any tool calling LLM, right? So there you go. There, cool. See, running AliCat RAG remote. How cool is this, right? So what it's doing is this agent is discovering my tool and say, oh yeah, hey, this tool can answer questions about AI Alliance. Let me ask this tool about this question, and it's doing it right now. Hopefully, there you go, right? Neato, right? By the way, and this is how we are in software engineering, right? And this should just either make you happy or really make you scared. So last night at almost like 11:50, I said, okay, hey, take this. I used a coding tool. I said, take this query, 4.query.py, and turn this into an MCP server. And they did this in 2 minutes, right? So the code you see here, MCP server, this is completely AI generated, right? So what it did, it took my query and said, oh yeah, so that you are doing a RAG search. And if you see, it copied a lot of code from my file. You can see, right? You can see all the, right? See light LLM embeddings and everything. Yeah. And then it also added the MCP components on top of it. Exported. So this should be the final takeaway for you guys, right? Code is cheap or even free at this point. Right? So don't get too obsessed with writing code. Those days are gone. What you need to be focusing on as a developer is how to use these tools to amplify your output, right? I mean, if I wrote this on my own, I don't know, it would have taken me like an hour or two maybe. But the LLM did this in, say, 3 minutes. Awesome, right? And it was great because, I mean, there's no way I would have been able to do this at midnight last night. so I was really glad. By the way, just to show, I switch between two tools. One is Cloud Code, which is great, and the other one is Klein on VS Code. All right, guys, thank you so much. That's it. I'm going to have Alexi up.